Hello class, welcome to the final segment in the week 13 material, and on this final segment we're going to take a look at something called the PlotPixels function and also something called the SetSignature function, but the thing you want to focus on is the PlotPixels function. And I want to go ahead and get this out of the way right now. The PlotPixels function is something that is user defined. It's not something that you're going to be able to universally use, but it is sort of kind of builds up your skill set of working with functions that have been built by someone else to serve some specific purpose. So that's the main idea behind what you've got going on here. And these two functions are in fact contained within a file called HappyPlotToPy, which is located on the class server. When you go to the week 13 tab on the class website, you should see a file path or a sentence giving you the file path to the HappyPlot2.py. So hopefully you remember how to use the copy function to bring the HappyPlot2 file over into the directory where you've got your Python program. And I'll go ahead and mention while I'm on that topic, in order for this program to work, HappyPlot2.py has to be in the same directory as your Python program. So right now my Python program is called w14p1.py. If I type an ls command, you can see here's my w14p1.py file. That's my Python file, which is given by what's up here. And also notice in the same directory I have happyplot2.py. If these two files are not in the same directory, it's not going to work. So make sure when you copy the happyplot2.py file over, make sure those two Python files are in the same directory, otherwise things aren't going to work. So now with that out of the way, I'll go ahead and explore a couple of the functions that are contained within the HappyPlot module that you guys are going to be working with. So the first of which is a SetSignature. When you go to the PlotPixels function generates a graphic, it generates a picture which has a sea surface temperature data plotted on it. The SetSignature function basically puts a watermark on the image, and this is basically how you'll put your name on the image files that you guys are creating for the final assignment. So inside the SetSignature function, you're going to want to put your 4x4 in here. That way we know who exactly plotted which pictures and posted them onto the web pages. So that's another part of the assignment, is posting the pictures that you created onto a web page. So hopefully you are pretty familiar with how to do that from the week 12 assignment. So again, the SetSignature function, that's where you put your 4x4, and that's how you're going to be putting your name on your images. And then after that, it's pretty much the exact same thing that we had before. So again, this retrieves the data from the netcdf file, pulls the individual arrays out of the data set, and then puts them into a Python variables, which are a little bit easier to work with. So again, the data is holding onto our sea surface temperature array. Longitude, in all caps, is holding onto our array of longitudes. Latitude is our variable that's holding onto our latitude data set. And then our time variable is holding onto our time values. And then now finally we get down to the bottom here where we have the PlotPixels function. So the way the PlotPixels function is set up, so of course we have PlotPixels, and then the first value that you pass the PlotPixels function, that's your array of longitudes. That corresponds to what's on line 25 up here. So whatever array is holding onto all of your longitudes in the data set, that's the array you want to put in for this first value in the PlotPixels function. Then finally not finally, finally in one sense, but not in the sense of the PlotPixels function. This latitude, the second value that you put in the PlotPixels function is in fact the latitude. And again, that is the array of latitudes that you're holding onto, which corresponds to what's defined up here on line 26. So the second value that you have to put in here must be a one-dimensional array of latitudes that you get from opening the netcdf file, which is the process that goes on line 26. And he just froze. There we go. I was a little worried there for a minute. And then the third value that you pass the PlotPixels function is a two-dimensional array of sea surface temperature values. And you also want to make sure that the array that you're passing it is a 170 by 180 array. That is all the latitudes. There's 170 latitudes by 180 longitudes. If this is not a two-dimensional array, this third value in the PlotPixel function, if this is not a two-dimensional array, you're going to get an error message. if this is not a 170 by 180 two-dimensional array, you're going to get an error message. So take what I said, again, drill it into your brain, do whatever you need to do to remember what I just said. The third value you pass the PlotPixels function must be a two-dimensional array. And you might be wondering, hopefully, you might be wondering, how exactly is this a two-dimensional array? Hopefully you remember back from week 9 when we're pulling an individual entry out of a multi-dimensional array, we lose a dimension. So here I'm saying pull out just a single time value given by 0. So this is the very first time value, which corresponds to January 2001. So that's the time value that I'm pulling out. And then remember the colons here, just the lone colons means I want all of the latitudes and I want all of the longitudes. So single value pulling out of a three-dimensional array. If I pull just a single entry out, that gives me a two-dimensional array. But since I'm pulling multiple latitude and longitude values out, that still leaves me with a two-dimensional array. So this, in essence, right here is going to plot all the sea surface temperature values in January 2001, which is what this 0 in the time slot corresponds to. And then scrolling on over to the right here, high C is a parameter in the function that sets the high bound for a color bar, and low C sets the lower bound for the color bar. And I'll tie back to what's actually going on here in just a little bit. And then title is the title of the graphic, which is, sorry about that. Title is going to be the title of the graphic. I did it again. Take 3. Title is going to be not cooperating with me. There we go. So this title value that you see in here, which my computer for some reason does not want to highlight properly, that is in fact going to be put in large letters at the top of your graphic. So you can sort of think of this as the title for your graph or some sort of data plot. And then finally, this other bit out here, out file, that specifies where you want the file to actually be saved. So this is going to generate a plot of data and is going to save that data to this file called January2001.png, and this is going to be saved to the same directory as your Python program. So if we want to see what we actually get from running that program, we can do that by the Python command, $ampersand. It's become a bit of a habit. I also have the print nc.variables. We don't actually need that. Hopefully by now we know what all is being stored in there. So here you can see it printed out a bunch of text, said save plot to January2001.png. And when you run this for the first time, you probably also get a message saying created pi cache with underscores. You don't have to worry about that. You're only going to see that once. The main thing you want to look for is to see if the image file actually got generated and that you're not getting any error messages. So if we type the ls command, there's the image file that we created. And if we want to see what that looks like, we just simply use the EOG command like we've done before. And there you can see we do in fact get a nice pretty picture. So again, this right here, January 2001 sea surface temperatures, that corresponds to this title that we have being passed to the PlotPixels function. And the high C and low C, remember that corresponds to the color bar. There's the color bar. And this low bound of 270, it didn't actually label it, but this lower value on the color bar is in fact 270, and this high bound on the color bar is in fact 305. And then the other thing that you'll notice is this watermark that appears in the bottom left-hand corner, which corresponds to this command up on line 16. And you may recall earlier I said that's how you put your name on the actual graphic. That's what I meant. You're going to put a watermark on the bottom left-hand corner. And one thing I'll also go ahead and mention, the low C and the high C values, those correspond to the values that you're actually plotting. So in the case of our data set, we're plotting temperatures that are in Kelvin, and 270 Kelvin to 305 Kelvin makes pretty good sense. It seems like a nice sensible range of values to be plotting to a graphic, given the values that we're working with. Excuse me. If the values that you're plotting are not 270 to 305 Kelvin, then you're probably going to change the values of these to get a better display of the actual data. because if you end up plotting information that's, say, 1 or 2 Kelvin, which is actually going to be something that you're going to be doing, it doesn't make sense to have the low bound and the high bound set to 270 to 305 because everything is going to be much, much lower than 270 Kelvin if you're plotting something that's really small. So you might have to play around with some of the values here to actually get uh, something that looks easily interpreted, as opposed to it being just all blue or all red, which is the result. This is the result that you'll get if the values that you put in here don't actually capture the values that you're plotting. So if your values that you're plotting are all outside this bound here, if they're all less than 270 or all greater than 305, you're just going to get every data point's either going to be colored blue or red. There's not going to be anything in between. All right, so that's going to do it for the PlotPixels function and also all the material for the semester. So that's all the material that we're going to be introducing during the course of the semester. So the remainder of the semester is just going to be, you guys will have the opportunity to email me any questions that you guys might have. But yeah, I think that's going to do it. So hopefully what's in this unit makes some sense. Like I said, you may have to rewatch multiple videos to remind yourself how things work and to remind yourself some of the common misconceptions that you want to avoid. But yeah, I think that'll do it. So hope you guys enjoyed the class at least somewhat, and best of luck on finals, and also best of luck on completing the final assignment in this class.